Hi, in this and the following videos I'll be talking about ensemble methods. The two key techniques you'll see here is boosting and backing. Both techniques relate to the bias variance decomposition. You saw this in previous videos that related to learning theory. So the bias variance decomposition relates to the outer sample error rate. So remember, we have these two different error rates. We have the in-sample error rate of a hypothesis, and we had the out-of-sample error rate of a hypothesis. So this thing is something we can actually compute. It's a concrete thing we can compute, and this is typically what we try to minimize. But what we really care about is the outer-sample error rate. So in the bias variance decomposition, we saw that the outer-sample error rate can be decomposed into the bias of our hypothesis and the variance of our hypothesis. So I'll just try to give you an abstract idea of how you can think of bias and variance. In the following videos you'll get a more mathematical formal way of coming about it. But so you can think of it as playing a game of darts. So let's say I have four boards of dartboards. So in dartboards you also have the bullseye in the middle, and this is the target. This is what you want to hit. So let's imagine that over here I have low variance for these two boards and then high variance over here. So I'll be throwing a lot of darts at these dartboards, and I'll represent where they hit with dots. So then we could imagine that these dartboards, when I throw over here I have low variance, and when I throw over here I have high variance. Then when I throw on these two guys I'll have low bias, and when I throw on the last two guys I'll have a high bias over here. So if I have low bias and low variance, you would expect the darts to look something like this. They would deviate little from each other's mean because there's a low variance, and they would deviate little from the target because there's a low bias. Over here I would have a high variance, so I would expect to see something like this. They would deviate a lot from the mean of all the dart throws because the variance is high. They would vary a lot all of the dart throws compared to each other. So now if I had low variance and high bias, then I could expect to see something like this maybe. There's a low variance, so they won't vary a lot compared to their mean, but I'll expect them to be far away from the target. So I mean, they could also maybe be over here, but this could be something that could happen. So then in the last case, this is where everything is bad. Then I have high bias and high variance. Then I would expect something like this, right? So they would vary a lot compared to each other, and they would also be far away from the target. So these are the four cases of low, high variance and bias. So the idea of backing is to fix the variance problem. So if you only have the variance problem, then backing tries to move you from high variance to low variance. So backing is a technique of decreasing variance. Similarly, boosting is a technique where I try to go from high bias to low bias. So this technique here is boosting. So if you only have the bias problem, then boosting will try to increase or decrease the bias of your model. So these are two different techniques of trying to fix two different problems. So typically the outer sample error rate will consist mostly this one of the terms will really be bad, and then we'll be able to use one of these techniques to fix this and get a better outer sample error rate. So this is what we'll consider in the next following videos. We'll first revisit the bias variance decomposition, see these proofs again. This will be the next video, and then there'll be a video on backing and a video on boosting.